Afternoon, ladies and gentlemen. It's a pleasure to be here for this second plenary session of the CU event. I will introduce you our chair for this session. She is a professor at our physics department. She was our most cited researcher at UFPR in 2019. She's a lead researcher in Brazil and in the world at Meteorology and Climate. Please welcome Professor Alice Green.
Thank you very much, Anna. Welcome to this plenary session related to the Sustainable Development Goal number 13, in short SDG 13, within the conference held by the Federal University of Paraná on the UN Sustainable Development Goals. This SDG 13 is about climate action, urging everyone to take action to combat anthropogenic climate change and its impacts. It is therefore a matter of great concern worldwide. I would like to thank the organization of this event for inviting me to coordinate the program related to this SDG 13. In the two related sessions, which are this plenary session and the following panel session, we will have very high-level speakers informing us on topics of great current interest, such as sustainable economic exploitation of the Amazon forest, the climate change science and its role in constructing a sustainable world, the content of the latest IPCC report, and Brazil's contribution to the achievement of SDG 13, the removal of carbon dioxide and nature-based solutions to combat climate change, and finally, other possible effects of Amazon deforestation besides its contribution to the greenhouse gases content in the atmosphere. I'm very pleased and honored to welcome Dr. Carlos Nobre as the speaker for this plenary session. He is a scientist recognized for his work on biosphere-atmosphere interactions and climate ecological impacts of Amazon deforestation and global warming, working especially with the risk of savanization of this biome. Carlos holds a PhD degree in meteorology from the MIT, USA, and has worked for more than 35 years at the Brazilian National Institute for Space Research, the INPE. He has been an architect for the establishment of a number of research institutions in Brazil, including the Brazilian Center for Weather Prediction and Climate Studies, the CPTEC, the Center for Earth System Science, and the National Center for Monitoring and Early Warning of Natural Disasters. He was one of the architects of the large-scale biosphere-atmosphere experiment in Amazon, the LBA, and its first program scientist. He has been scientific director of the Brazilian Research Network for Climate Change, chair of the International Geosphere-Biosphere Program, member of the International Panel on Climate Change, member of the UN Secretary General Scientific Advisory Board for Global Sustainability, and one of the co-chairs of the Science Panel for the Amazon. He's a member of the Brazilian Academy of Science, the World Academy of Science, and Foreign Associate of US National Academy of Science. Carlos has also worked in science policy interface as National Secretary for Research and Development Policies and was president of the Brazilian federal agency for support and evaluation of graduate education, the CAPES. He is author or co-author of over 250 scientific papers and books and chapters of books, and has received a number of scientific awards. Currently, he is a senior scientist at the University of São Paulo's Institute for Advanced Studies, and he is championing the so-called Amazonia 4.0 project, a science-based initiative to develop a standing forest bioeconomy for the Amazon. This is one of the themes of his talk. At the end, he will answer questions sent by the audience. If it's not possible to answer all of them, he can, and he will do it in the next session, which is a panel session starting at 3 p.m., featuring 4 presentations and a roundtable discussion at the end that will include comments and questions from the audience. Carlos, I thank you for being here, and the floor is all yours.
Thank you very much, Alice. Good afternoon, good morning, good evening to all of you. Boa tarde para todos. Thank you very much. I think it's very important discussions, and it's a pleasure to talk about the Amazon. I will share the screen if you give me just 1 second. And also I have to apologize because many of my slides are in Portuguese. I did not have the time to translate all of them to English. But anyway, well, you know, many of us, we have been working in the Amazon, in the beautiful forests, diverse forests, very diverse from the Andes all the way to the Atlantic, a very efficient rainfall system, the most biodiverse place on Earth, and also with the largest river, and as I mentioned, immense biodiversity. So we've been very much engaged in Amazonian research, and so I will talk about the Amazon being very close to tipping point, and also because this is a Sustainable Development Goal meeting for SDG 13 climate action. So I will also address why we need urgently to develop a new bioeconomy, a standing forest bioeconomy. And also I have to say that after I retired from INPE 5 years ago, I decided to do something different, although I'm still advising students in climate modeling, etc. But I'm trying really to develop a project which is seeking sustainable solutions for the Amazon, what I call Amazon Green Deal. Just a second. So I will cover the 3 first topics about the risk of the tipping point, and then a 4th, which is seeking this innovative, sustainable pathway. First, the Amazon as a regional entity of the Earth system. Decades ago, if you are my age or older, you remember the Amazon was seen as a green hell in books, in movies, distant place, a green hell that, you know, the modern civilization had to get rid of the green hell. However, if we look at the traditional populations which arrived in the Amazon 12,000 years ago and created a very large number of different ethnic groups, when the Europeans came to the Amazon, 1500, year 1500, there were about 8 to 10 million people, over 1,000 different ethnic groups, and they always have seen the Amazon as a green paradise. And the modern science, let's say the science that we really develop in the Amazon, and many of us, all of these people, the speakers of this session, and also Alice and many others, we've been working for many decades in the Amazon. And so this sums up a little bit, the Amazon is a key player in the global carbon cycle, removes CO2 from the atmosphere, stores a lot of carbon, the most powerful hydrology, the most biodiverse place on Earth, more than 10% of all species. Also very important, climate stabilization, water recycling, and also still helps to maintain a cultural and ethnic diversity, more than 400 indigenous groups, 2.5 million indigenous people. So it's really a green paradise for planet Earth, and the science has shown that. Qualitatively, let me just tell you, the Amazon forest only exists because the forest exists. Let me explain what do I mean by that. Over millions of years, the Amazon forest evolved, reaching these accomplishments, a very high plant and animal biodiversity, as I mentioned, very efficient recycling of water, very efficient recycling of nutrients, that all 84% of the Amazon basin soils, particularly the plain, they are very poor of nutrients. So the nutrients are in the biomass, are in the trees and the plants, and the very wet biome blocking fire spread. So this is an evolutionary ecosystem interacting with climate for millions of years. And also it pays out a lot of important services to the Earth as a carbon storage and sink, and moist air exported outside of the basin, the area of flying rivers. As I said, the forest stores and also removes the undisturbed forest, removes now about 1 billion tons, but decades ago it was 2 billion tons of carbon dioxide. And just summing up this, oh, by the way, I have to say, we released during COP26 the results of the science panel for the Amazon. We put together over 200 authors, 60% from Amazonian countries, and we for the first time we did a rigorous scientific assessment. It's 1,350 pages, 34 chapters, and the first part of this report is the Amazon as a regional entity of the Earth system. The second part is what we are doing to transform the Amazon, and the third part is the solution space, how to construct a sustainable future. So the first part really sums up. This figure comes from the science panel for the Amazon report, and this is the evolution: deep roots, bringing water, spreading water near the surface, also water for trees to transpire, very efficient recycling. 28% of the rain in the Amazon basin is due to the recycling. You see here this big arrow, because most of the solar energy, the net radiated energy, goes into evaporation, transpiration. Very important mixing. Emissions of volatile organic compounds become nuclei for clouds. Very efficient recycling, very efficient cloud formation. And I'm not going to say, because you are going to have a wonderful presentation by Gilberto Fish about these aerial rivers, the importance of this export of water from the Amazon to Central South America. So Gilberto will cover that. So this is evolution of millions of years, and this evolution is very linked to the largest biodiversity on the planet. 1 hectare, 10,000 square meters of Amazon forest has more tree species than all of Europe, something like 350 different tree species. Also, all these more than 50,000 plants, insects, primates, amphibians, reptiles, birds, and fish. So this is the most, and this is very important, it's biodiversity, particularly of the plants, but also depends a lot on these animals and also, of course, on microorganisms, microfauna in the soils. So this is unique, similar to other tropical forests, but very unique in the Amazon. So, however, we are overseeing a deforestation and fire in the Amazon. This is really starting in the early 1970s in Brazilian Amazon, but also spreading in all Amazonian countries. We have seen the so-called, quote unquote, the development model practiced in the last 50 years. And the let's say, economic mandate of this development, quote unquote development, was trees are obstacles to development. And burned trees are fertilizers for pastures. So that was really, because as I mentioned before, the soils are very nutrient poor. So, and most of the nutrients are in the forest. So that was really the driver of the so-called quote-unquote development model, which still persists. So this is really most to replace the forest with pastures. Most of the pastures really degraded and continuous use of fire and very high emissions. And sometimes you see this, for people who know the Amazon, it's very common to see that. This is a Brazil nut tree. Since 1920s, it's against the law to cut down Brazil nut trees because of the economic value of the nuts. However, only 4 bees pollinize the Brazil nuts. And 3 out of those 4 do not survive the hot temperatures of pasture crops like that. So the Brazil nut trees standing alone, usually they die after a few years. So this is a painting, just to give you an idea, of the Atlantic forest, 1843. Then you see the forest on the right-hand side, you see deforestation, and then you see the fire. And this is almost 200 years ago, and this is exactly what the Amazon is still seeing. We had a spike in fires and deforestation in 2019. So it's really very compelling that the model of development that reduced the Amazon forest, the Atlantic rainforest, in the 19th century and 20th century, we are still seeing that taking place in the Amazon. And of course, the main driver is roads. When there is a road, you start seeing a lot of the 95% of all deforestation sits within 5.5 kilometers on both sides of roads. This is in Rondônia, the small plots for colonizers, for people invited in the 70s and 80s to go. Millions of people became settlers there in these 100-hectare plots, and then they deforested most of those, and also big cattle farms, and you see here. So this is really what we are seeing unfolding in the last 50 years. And this is the deforestation rates for all of the Amazon, 2000-2018. So it's mostly the southern and near the Andes as well. Currently, we are 17% of the Amazon has been deforested, clear cut, mostly in this arc of deforestation in southern Amazon, eastern Amazon as well. But also we have really to start paying more attention also to forest degradation. You see here, this is start with selective logging. In Brazilian Amazon, 80% is illegal. You see here a patio for where they bring the logged trees, the timber. These trails where they take the machines, the tractor, the chainsaws, and then about 5 years later, you start seeing a loss of the under canopy, and then the canopy 50%, perhaps 10 years, and in 15 years, you have more than 90% loss of the canopy, and then you start seeing fire scars. The forest becomes very, very vulnerable to fire. And as I mentioned before, the undisturbed forest evolved over millions of years with only 4% of solar radiation reaching the canopy, reaches the surface. So the surface is a very, very humid microclimate. So fire does not propagate. A lightning strike ignited fire does not propagate. So this is the evolution of the forest, very unique. So also this is the degradation. 17% of the Amazon basin is also several stages of degradation. So we really have to compute always not only the impacts of deforestation in risks to biodiversity, losing carbon, and also reduction of rainfall, increase in temperature, as I mentioned, increase in dryness, but also impacts of degradation. For instance, in the national greenhouse gas inventories in Brazil, officially, they do not add the emissions from forest degradation. And if you compute 1 hectare of forest degraded emits something like 53% of a clear-cut forest. So this is also one problem for climate change, this very accelerated forest degradation. And also in the border between, like here, the border between the forest and the deforested area, this border forest becomes very vulnerable because there are stronger winds, more solar radiation drying the forest. So fires escape from this pasture and penetrate into the forests and degrade it even more. So, so we really have to then to ask how close we may be to a tipping point. And so there is this anthropogenic drivers, forest degradation, clear cut of the forests, and also fires, as I mentioned. You see here a very large area showing the fire scars, and this one shows the areas deforested and also degraded. So basically, you know, this deforestation, degradation, and fires, you have changes in the carbon cycle, hydrological cycles, impacts on human health, including. So we may be close to tipping point. I want to address that now. This is a summary, and I'm glad to be doing this this presentation in a session which also Gilberto Fish is here, and Gilberto was also, I was there in the first experiment in 1983, in which an international group of scientists started looking at how the forest interacts with the atmosphere. That first experiment was only forest, but then almost 40 years of field research, including the LBA experiment. So there were many, more than 20 sites in which there were micrometeorological towers measuring water vapor fluxes, heat flux, CO2 flux, methane flux between the forests, either the forest or a degraded pasture. So basically, this diagram sums it up. I'm not going to go into all the details, but this is all based on observations. This is not a modeling, but just the forest has a rougher surface, which makes the wind more turbulent. So it supports a more effective interaction between, exchange between water vapor, transpire here and the lower atmosphere, also CO2, and a deep, I mentioned before, a deep rooting system. Let's say in the winter, in the dry season, some roots are bringing water from 7 to 10 meters and spread the water in the surface, so other trees capture that water. So in the Amazon, there is more evapotranspiration during the dry season, unique aspect of the, and also photosynthesis is higher photosynthesis, most of the Amazon during the dry season, 3.5 millimeters a day, up to 4.5 millimeters a day during the dry season. So most of the energy, solar energy becomes, is used for transpiration. So it's cooler, the maximum temperature is 30 degrees. That's how this forest evolved over millions of years. And the less vapor pressure deficit, so it's a humid air. So, and because of the turbulence, it's stronger water recycling and much more rain. So when you replace by a degraded pasture, much shallower rooting system, so it becomes very dry in the dry season, 1.5 millimeters a day in the dry season, much warmer and drier, higher vapor pressure deficits, 1.5 to 3 degrees warmer on average, and maximum temperature reaching 35 degrees. So you see, and because of that, smoother surface, much less effective water recycling, drier surface atmosphere, weaker water recycling, when we are already, many studies shown 10 to 20% less rainfall, mostly during the dry season. So this is due to deforestation, degradation, and global climate change. So, and that is also seeing a delay on the onset of the rainy season. So this is just a summary. So basically, we are very close, how close we are to this Amazon tipping point, in which the forest might remain only over Western Amazon, near the Andes, because it's a lot of rainfall, 3 to 5 meters of rainfall, and perhaps 50 to 60 to 70% will become open canopy, we call quote unquote degraded savanna, not necessarily as rich as in biodiversity as also in carbon content as the tropical savanna, the cerrado, but a very degraded ecosystem. So also this is because of the synergistic interactions between large scale, the tipping elements of the global climate. I don't have the time to go in details with all of them, but just to tell you, the melting of the Greenland ice sheets, they are bringing fresh and warm and less dense water here. This is affecting the Atlantic meridional overturning circulation. And a result of that is that the subtropical North Atlantic, tropical subtropical is becoming warmer, and this is inducing more droughts here. So so this is a large scale effect linked to other tipping elements of the climate Earth system. And also, of course, you have the global impact and the regional impact, deforestation, forest degradation, less rainfall, hotter and longer dry season. So this combination may really put the Amazon at the edge of a cliff, of a tipping point. And we are seeing that. And so, of course, this positive feedback, which is tree loss, less evapotranspiration, decreased rainfall, longer dry season, less humidity, more fires, more tree losses. So we are already in parts of the Amazon, more than 2 million square kilometers, in this positive feedback, which might really lead to this abrupt change, tipping point to a different degraded ecosystem. I don't have the time to give you all this detail. There are many studies. I just want to very briefly, climate extremes are becoming droughts and floods, more frequent, longer dry season, particularly in the degraded areas, much more vulnerable to fire, as I mentioned before, reduction in water recycling in southern Amazon, removing much less carbon dioxide from the atmosphere. Mortality rate, very, very concerning. Mortality rate over 2.5 million square kilometers in the Amazon, mostly southern Amazon, but up to northeast Amazon. There is an increasing mortality rate of wet climate tree species. Even we are starting to see savanization of the fauna. So, you know, if you are a meteorologist, you should be very concerned, a climatologist, because this is observations showing the increase in the duration of the dry season. 3 to 4 weeks longer, over 40 years, almost 1 week per decade. If this dry season becomes longer than 4 months, this is the climate envelope of savanna. So basically, what the Amazon stores 150 to 200 billion tons of carbon above and below soil. So is this going to become a carbon sink or a source? I just want to tell you, this is a summary for the science panel for the Amazon. When you put together the emissions and the removals, it's 220 million, much less. Red is emission, green is removals. And an important paper by Luciana Gatti et al., I'm one of the co-authors, published this year in Nature, look at results from over 500 flights measuring CO2, methane, CO in these 4 regions. And let me just focus on here in this southeastern part of the Amazon, 26% deforestation, 24% less rain in the dry season, 2.5 degrees warmer in dry season. And this green is what the forest removes of carbon dioxide. This is positive. So the forest here, I'm not talking about the emissions from fires or deforestation, I'm talking about the forest is becoming a carbon source. Very, very concerning. This from IPCC AR6, released in last August, showing in many scenarios, future scenarios, the Amazon is a carbon source. Very, very dangerous. And this is just animation, what might be this removal, this quote-unquote savanization, in which most of the forest, 50, 60%, even 70% of the forest would only remain close to the Andes. So basically, we may be very close to this tipping point if we exceed perhaps 20, 25% of total deforested areas, and we are increasing more than 1% of the clear cuts. And if we add the forest degradation, and most of the model studies have not considered forest degradation, probably we are much closer to the tipping point. So let me just move now to looking for solutions. Can we avoid this tipping point? And basically, it's up to us, like, you know, COP26 and climate change research shows, really avoiding a tipping point for the climate system, for the planet, depends on us, as COP26 made very clear. 1.5 degrees, no more than that. Reduction of 50% of global emissions by 2030. The most challenging decade in human history or human civilization. It's almost very difficult even to conceive how we are going to reduce 50% global emissions. But for the Amazon, the same. Basically, no, this is the dystopic trajectory of the Amazon, but we can have a utopic trajectory, which is a sustainability trajectory with zero deforestation. So it's possible to have economic development without fire, deforestation, degradation. Of course, 50% of the Amazon is indigenous territories, protected areas, and but they are seen as an obstacle to development, and also this is indigenous territory. Xingu is becoming very sensitive to climate change. This is fire scars after the 2010 severe drought. Or what we call second way is the current model, forest as an obstacle to development. And as I mentioned, this is Brazilian deforestation. More than 20% has been cleared. The occupation of the Amazon will follow the cattle's footstep. This is a sentence said in 1972 in the beginning of this occupation of the Amazon, and this is indeed what's going on. Whether we want to transform the Amazon is a big crop farm or a cattle ranch. Economically does not make much sense. Very little productivity in even soy or cattle or timber. 90% of the first deforestation is usually cattle for pastures, but only 63% remains as cattle. 22% is abandoned, showing a very inefficient cattle, 14% in crops and mining. So basically, we have to see whether there is an opportunity. Should we really do something to find a third way of sustainable development? And that's what we are doing. Certainly, we need to have a moratorium on deforestation, forest degradation, and wildfires, huge forest restoration, but also we need a standing forest bioeconomy. And I will talk a little bit about these ideas that we are developing. The Amazon Third Way is a new standing forest. This is basically how to bring together traditional knowledge with modern scientific Industry 4.0 to harness the tremendous biological assets of the Amazon forest. I showed again most biodiverse place on Earth, but in the Brazilian economy, products of the biodiversity are only 0.3% of our GDP. So really, we have the most biodiversity in the planet, the Amazonian countries as well, but we never made that economically. Lucrative cattle is $100 of profit per year per hectare. The most profitable soy in the Amazon is $200. Acai berry in agroecological systems, $1,000, improves considerably the lives of all those people running those agroecological systems. Agroecological systems are a very good solution for degraded, deforested areas. They store, sometimes after 25 years, 70% of the carbon. They keep 65% of the biodiversity. So this is the way really to go. How to develop this new economy, and that's what we are saying, how to develop a new bioeconomy with modern industries for many products of the biodiversity. So that's the project we call Amazonia 4.0, and I will briefly just go through these three initiatives. One is the Amazon Creative Labs, another one is the Rainforest Business School, and a third one is Amazon Institute of Technology. This is a sentence by a former Minister of the Environment of Peru. We really have to develop new technology, but they have to be Amazon proper technologies. Let me tell you first of this Amazon Creative Labs. The idea here is to have this portable moving labs, which are small scale biofabrics with very modern technologies, and to do capacity development of communities of producing forest products. We finish this project for cupuaçu cacao. Cupuaçu is a very close relative to cacao. And we are finishing the construction. We have designs of these other two, seeking funding, and we also starting designs for high quality cooking oils, gourmet oils, and also acai. For the cupuaçu cacao, we are, as I mentioned, there are over 1,000 varieties of cacao species in the Amazon. This is the indigenous people over thousands of years. So you can have very special, this cupuaçu, very special And of course, industrialization is what adds value. Just to give an idea, 1 kilogram of seeds of cacao, 10 reais versus 1 kilogram of high quality chocolate. So the idea here is the so-called tree-to-bar chocolate making for cacao, cupuaçu, all the way to make fine chocolates. We are constructing the first laboratory here in a technological park in São José dos Campos, which has very high industry 4.0. I don't have the time to go in all detail, to make sure to produce a very important, very high quality product, not only chocolate, but many products. This is the tent that will house this small biofabric. This is the team putting together, including many of these people. This photo shows people from the Amazon. They came for starting this capacity development, but the capacity development will be carried out in 4 different communities: Tocantins, Low Tocantins River, Quilombola community here, a riverine community, Acará River, Moju Miri, Quilombola, Cacau, and the Amabela Association of Women Producer of Cupuaçu, and also the Resex, Tapajós, Arapiauns, many communities producing cacao and cupuaçu. So this is, Ismael is the scientific director of this project, visiting all these communities, and so they are all engaged, and in 2022, this exercise will start. And we have a partnership with IADB, the Inter-American Development Bank, funding these exercises, and the Connexus NGO, and basically the idea is to construct as pillars of sustainable development these ecosystems of innovation, sustainability, and sustainable business. So the idea in these communities and also in urban areas is to put together a lot of effort and also financing for making these biofabrics and adding value to the products of the forest. So this is as I mentioned, one of the elements, important elements, bio-industrialization of forest products. So Amazonia 4.0 also, we are developing in partnership with the University of São Paulo, State University of Amazonas in Manaus, the Rainforest Business School. They just started the first MBA course a few months ago. So basically, there is no Rainforest Business School in the tropics. So we really have to create a business school to give the proper education for future entrepreneurs, ecopreneurs, startups, and have a forum to discuss this new bioeconomy, to assess the risks, environmental, economic, social risks. So that's the idea. We are developing an online platform to have a lot of material for education in the sustainability of business in the Amazon. And last but not least, in the Amazonia 4.0, we are developing a pre-feasibility study led by Professor Adalberto Val, former director of INPE Manaus, myself, and many other people. The idea here is really, I was very happy in my professional life because I did my undergraduate in electronics in ITA, Aeronáutica, Instituto of Technology in São José dos Campos, and then I did my PhD at MIT. So I could see the importance of having a high-quality technological institute. For instance, ITA, I started my undergraduate in 1970, 1 year after the 3rd largest aircraft company in the world, Embraer, was started, and they were all started with ITA's engineers. And so Embraer really could not have developed without ITA. So I could see how important it is to have a high-quality Institute of Technology. The Amazon has never had such a high quality. So that's why we are proposing a pre-feasibility study, just to give you just an idea to become a global reference for technological innovation through the sustainable use of the inherent information in the Amazon rainforest, including the knowledge of traditional population. So basically, it's the institute which we are planning. It might have between 5 and 6 innovation laboratories for water, for Amazonian people, forests, biodiversity. So those in the right-hand side here are some of the elements of this, what we are proposing, the components, one for health and tropical medicine, sustainable material economies within the forest, terrestrial, and aquatic ecosystems, distributed manufacturing to bring value chain to communities, rainforest building technology, educational models, personal recruitment, outreach, and business and economy supported science and technology and innovation. This is the Rainforest Business School, if we are able really. And this is to be pan-Amazonian. This is not only Brazilian, pan-Amazonian, and also a public-private partnership. We are just really drafting the ideas, and we are totally open to collaboration. But we hope really to be able to convince that for a sustainable development of the Amazon, we need an Amazon Institute of Technology, quality of ITA, the quality of MIT. In fact, MIT is also partner in developing this pre-feasibility study. It's something expensive. We estimated that to construct a quality research center for education, for research, top-notch research, innovation, it would cost something like $500 million. Is it too much? No. If you look how modern economies, developed nations, China, even India, South Korea invests in research centers of high tech, it's hundreds of millions to $1 billion. So we really have to convince the world that the Amazon needs such institute. So I'm finishing in a couple of minutes. Looking ahead, what's the real advantage of a biodiversity-rich countries such as the Amazonian countries and the concert of nations? Are we happy to be providers of only commodities, as we are already and becoming more and more? Or also providers of added value products of the richest biodiversity on the planet? So this is the idea. So looking ahead, should we think about becoming global leaders in the global sustainable economy for this century that we need so much to preserve the planet, to reduce emissions? I did not mention that figure, but if we cross the tipping point, we may, in 30 to 50 years, emit 300 billion tons of carbon dioxide, making it impossible to reach the Paris Agreement targets of 1.5 degrees, because to have 66% of reaching the Paris Agreement, we can emit at most 500 billion tons of carbon dioxide, and only the Amazon would lose 300 billion or more. So this is the idea, this decentralized bioindustrialization, keeping into account this tremendous diversity of the Amazon, and that would really be very important for planetary health, becoming environmental powers of the social biodiversity. However, we still have this big challenge, which is the traditional populations for thousands of years, they have been living and well with the standing forest. So they have much more knowledge than we do. They use, in thousands of years, thousands of different forest products for food, for drugs, for other use. But we have to combine that, it's a big challenge, with scientific knowledge. And this is the idea, what I call Amazon Green Deal, nature-based solutions to create the circular bioeconomy of standing forests and flowing rivers, but at the same time, creating jobs, well-being, income, prosperity. At the same time, we protect biodiversity and combat climate change. So that the vision is really to keep as a forest full protection, 60-70%, 15-20% sustainable forest management for this standing forest bioeconomy, and only 10-15% in intense use of productive agriculture, not the agriculture we have today, legal mining, not the illegal mining we have today, and the sustainable green in urban infrastructure. The president of Colombia, Ivan Duque, created this sentence a few months ago. The standing force by economy is producing for conservation and conservation for producing. So we have to maintain the forests to produce this tremendous potential, economic potential of the biodiversity, but also we have to produce to really improve the livelihoods of the people in the Amazon and also the economy of the Amazonian countries. So basically, that's the idea. To protect most of the rainforests, we have to stop to get zero deforestation, a moratorium on deforestation, degradation, wildfires, and then to create this new social economy, social biodiversity-based, respecting, including, and empower indigenous people and local communities. Thank you very much. I'm sorry I extended a little bit more of the time you gave me. Thank you very much.
Professora Alice tá mutada, tem que religar o microfone.
I was muted. Okay. Thank you, Carlos, for this wonderful talk, for this very enlightening talk. It's very necessary to offer and discuss options in which the forest can sustainably provide the livelihood of the local communities. I would have two questions for you, but since we have to open the next panel session on this sustainable development goal number 13 before 3 p.m., we will have to close this plenary session now. And then, as you will also participate in the roundtable discussion in the next session, I will pose these questions, make these questions in the next session to you. And questions from the audience will also be forwarded to you in the next session. Okay, so then we close now this session, and in a few minutes, the panel session will be open, and we'll have 4 talks from very renowned researchers on very interesting subjects. And after these talks, we'll have a roundtable discussion. So see you in very few minutes.